Hello, good morning or good afternoon, depending on where you are around the U.S. My name is Andrea Hall, and I am the Customer Relationship Manager here at Saratech, and I'd like to welcome you to the next installment of our Customer Enablement Series. I'll be your host today, and presenting today, I'm proud to say that we have Edwin Abrahamian. He started out here at Saratech recently, but he has been so great, and he is really excited to do this webinar today on FEMAP 11.4. I'm sure that you are all so excited to hear about what's coming up, what's new. First, I wanted to tell you a little bit about this Saratech Enablement Series. I can see we have some regulars here, so I'm so happy that you all are returning month after month to come and see these free trainings that we hold. They're usually twice a month. They run 30 to 45 minutes or so, and they're always led by subject matter experts, developers, power users. And we have, over the course of the last year or so, we've been able to cover many topics, including FEMAP, Solid Edge, NX, Team Center, and we have lots more coming for the remainder of the year, some exciting topics coming up. So be sure to check out our website to see those that are coming up. You can register. Our goal for the Saratech Enablement Series is to help you get the most out of your software, to share knowledge amongst each other, and really just to build a community of users that will help empower each other with their PLM software. As always, this is an open forum, so we look forward to you participating in the training. If you have any questions or comments during the training, you could type them in that chat box over to the right-hand side or the questions box. There's two different places you can put those. We'll be keeping an eye on that. And if you happen to have any questions during the training, we'll find a time to interrupt Edwin and see if he can't answer your question on the spot. But if not, we'll be sure to follow up with you after the training. And with that, I'd like to pass the baton over to Edwin.
Alrighty. Hello all and welcome. My name is Edwin Abrahamian. I'm an application engineer with Saratech. This is a picture of me. And I am a recent graduate of UCI with a degree in mechanical engineering. And while at UCI, I got my hands on some design and CAE tools. So I've been exposed to that starting my freshman year in college. I graduated in 2017, this past June. I've interned with Saratech for about a year now, and now I'm full-time with Saratech as an AE. So I do have some experience with both design and CAE tools. I use FEMAP for multiple service projects with Saratech. On that note, we'll go on to explain what's new in FEMAP 11.4. So before we begin and delve into those new features and functions, this is a release schedule for FEMAP. So you can see that the most recent release was this past June, 11.4, and the general trend here is that every year there's a new release. So from 11.3 to 11.4, it took around a year. So expect something next year, year and a half for 11.5. What is FEMAP's direction? So FEMAP, I'm sure you all know, is a CAE tool, so computer-aided engineering, and the goal here is to essentially minimize your design process and get your products to market sooner. So that earlier you can do your analysis, the faster you can get your product out there. So FEMAP's direction with these updates is to maximize efficiency of FEA tasks and to build upon strong FEMAP capabilities. So this includes creating efficient creation of high-fidelity FE models that accurately represent real-world engineering problems. Additionally, to create an intuitive interpretation of analyses results to improve the design and performance of engineering products. So essentially, to sum it up, the goal here is to streamline your process as an analyst to model these different, parts and to perform real-world engineering problems and get the best results or output possible. Additionally, the geometry analyzation and processing for FE models has improved, powerful meshing, model creation, interactive editing, in-depth support for industry standard solvers, and flexible customization tools to, again, streamline your analysis process. This is an overview of what I'll be covering in the next 25 minutes. Some new functionality and updates include, they're included in these different categories, which is visualization. I'll be doing 2 demos in that to just show you firsthand what these new functions are. Meshing, pre-processing, performance charting, solver support. There's a lot of features with 11.4, but I just picked a few of them to demo for you that seemed interesting or are relevant. Let's dive right into it. So FEMAP 11.4, visualization. So this first tool is to show entities in auto scale function. Essentially, when you have a very complex model, you want to focus in on a particular part, a group, an entity of this model. Now you can not only highlight it, but you can go ahead and scale it. So all you'll be seeing on your screen as an analyst is that particular model or that particular entity. This helps streamline the process so you can go ahead and debug certain areas, etc. So I'll delve into that right now and explain it as I demo it for you all. So you can see it firsthand. So let's transition into my part here. This is the part I'll be using to show the auto scale highlight function. So right here I have a model that I've made. It's a truss structure. And I go here, I can go to my thickness, and you can kind of see what I've modeled here. There's a bunch of I-beams, there's some plates here. And what I want to do is, it's a fairly simple model, but let's say I want to focus in on a particular part of this model. So let's go ahead and hide this thickness here. I have a few groups here. So before starting this, I have my side truss curves, I have my side truss elements. I've broken down my groups into properties as well, but let's say I want to focus in on a particular group and not worry about the rest of the model. So I'm going to go ahead and select my property 2 flat plate. And if I go over to the top here where it says show when selected, I can make the drop down. There's a new option here, which is the auto scale to show entities. If I select that, go ahead and highlight it. You can see that now my whole group, the property 2 flat plate group, is highlighted, and the whole screen or your viewer perspective has auto scale, so you can see everything in that group. This is a powerful function. So let's say if you do a model check, you've already meshed your model or your geometry, you want to do a check, and you can make a group of your distorted elements. So let's say you have your Jacobian value is greater than the threshold, and then you have a lot of elements here that are distorted or it's not meshing properly. Then once you make a group of those distorted models, you can go ahead and do the auto scale highlight, and you can see exactly where those distorted models are. With 11.3, there's a lot of times when I myself was modeling, and I create a group of my distorted model, but it was hard to really see where these models are, especially if you have a very complex model. So this auto scale, again, changes your perspective so you can see them clearly. There's also another way to access this. You can go to your window, go to show entities, and you can go to you can select what kind of entity you want to see. So I want to see an element here. And the style, the auto scale option right here, that is new. You can check that, click OK, and I can go ahead and select which element I want to see. So I can go to, I want to see this element right here, highlight that, click OK, and you can see how it focuses on, highlights and auto scales to that certain entity. So it's a very nifty new function to, again, break down larger complex models and to view particular parts of the model, whether it be a group or particular entity. Let's move on. Also in visualization is the draw erase on previous selection versus entire model. I'll be demoing this one as well to give you an overview of the workflow here. So essentially what this new function enables you to do is, let's say you have a complex part, and from that complex part you want to make a selection. So you want to hide the rest of your complex model and just see a particular part of it. So you make the initial selection. So let's say you have a complex part here in the background. You make your initial selection, and from that selection, you can make a further selection. So you don't want this these elements on the outer area here. You want to just focus in on this particular part of your model. You can make a further selection. Again, this is to break down complex models, focus on particular areas of your model that you're having problems with for debugging, etc. So I'm going to go ahead and show this really quickly so you can see it firsthand what this function is and how it works. So this is the model I'll be working with. It's a fairly large model. So even just viewing it as a whole can be difficult on my particular view or perspective. And it's made up of a series of plate elements, and it's a map meshed. So what I want to do first is I don't want to focus on the whole model. I want to just focus on this particular area. So to begin, I'm going to make my first selection, my initial selection to hide parts of this model, but focus on just this area. So to do that, I'll go over to my draw erase draw mode, select that. I can go over to my draw erase select mesh. As I do that, I can change my pick method. I'm going to do, I can choose my pick method. I can go to polygon, After I do that, I can go ahead and create my polygon. So I want to choose this area. Okay, again, highlight it, click OK. You can see that the rest of the model is now hidden. So all I'm really seeing on my screen now is just this portion that I selected. Now with 11.4, I can break it down further. To do this is I can go to my draw erase select area to the dropdown and unselect or deselect this draw mode select from all option. As I do that, I can go back to my draw erase select mesh and I can do my polygon select. And I want to focus on just these two through holes, all right? So I can go ahead and select these, just like that. Click done. And you can see that the model I'm looking at is broken down even further. So again, this streamlines your process as an analyst. You can go ahead and debug certain areas, hide certain parts of the model that already look good, and just focus on parts that are distorted or you have issues with. Let's head back to our PowerPoint here. Yeah, I'm kind of moving through these functions to get as much to you guys to demo so you can see firsthand. If you have any questions or comments, please reach out to Saratech after the presentation and we can go through these functions and explain it further. Moving on from visualization, we'll go on to meshing. So with the meshing toolbox, you have FEMAP 11.4 enables you to auto update rigid elements. So right here, you have two through holes and you have two rigid elements, spider elements. And this emulates a fastener. Let's say you're fixing these two plates together. So you have two spider elements connected by a rigid element in between. When you go and increase the fidelity or the mesh density around these curves, you'll add nodes that define this through hole. And as you do that, an RBE2 element will be created automatically. So let me show you this. Actually, before I do that, let's say you have a disconnect. Let's say you have a node here, right? And your RBE2 remains disconnected. Okay, so in that case, if you try to increase the mesh density or the fidelity here, you'll get a warning. And at that point, it's up to the analyst to understand this and to go ahead and connect that node to that independent node in the center to complete your spider. And then increase the mesh density around your hole. So let me show you. I think it's always better to show than to just use words and explain it. So let's go to my model here. Okay. So I have two flat plates here, and they run parallel to each other, and I have two through holes. And as I said, like this in the real world modeling, this would represent, for example, a fastener running through and connecting these two plates. And I have a spider element, right? And this is made up of comprised of multiple RBE2s, rigid elements. If I go to my meshing toolbox here, go to mesh sizing, I want to increase the mesh density or fidelity of this through hole or this edge. So go ahead and click select here. And as I increase that mesh density, you see that I had around 4 RBE2s, now I have 5, now I have 6. And the number of nodes increases, and as the number of nodes increase, the number of RBE2s also increase. So it automatically updates for you. So as the analyst, this new function makes updating mesh densities and the fidelity of your model much faster, rather than going in and manually having to add elements. So that's cool. So let's say, however, that there's a disconnect. So let's emulate that disconnect. So I can do that by going to modify. I'll go to edit. I want to edit my element here. So let's edit this top rigid element. I'm going to select one of these nodes down here and click delete. So I want to delete these nodes to emulate a disconnect, right? So now that center independent node won't be connected to this particular node with an RBE2 element. Click OK to confirm that. Click OK. Now if I go to increase the fidelity or the mesh density around it, I can go ahead and select this curve. And you can see right here, potential rigid element disconnect at element 4 and curve 12. So it's telling me that element 4, which is this spider element right here, there's a potential disconnect between the spider element and the curve. So that means the analyst has to say, hey, so there's an issue here. FEMAP was smart enough to tell me that there's a problem. I can go in and manually create an element from that independent node in the center to the outer disconnected node. Alrighty, let's jump back to the presentation. So a couple more things. You have the ability to save vectors and planes. So this makes selecting your vectors and planes much faster. It's safe to the model. There's a vector and plane manager for the creation and management of your vectors and planes. And as I said, it's now safe to the model. So you can always go and access it. So now there's a new added saved method for both vectors and planes. You can see right here. Saved vectors and planes persist with the model and can be referenced at any time. And there's a running list of previous vectors and planes is kept, so you can reference them without even having to save them at all. So I'm going to go ahead and demo this function as well, so you can see it firsthand. The model I'll be using is this one right here. So this is a model of a wing of an airplane or an airfoil. So I'm going to go ahead and show you where the plane manager is. It's under Tools, Plane Manager.
Hey, Edwin, we actually have our first question, if you don't mind.
Sure.
Okay, so Dan is asking, just to confirm, regarding the rigid update during remeshing, does this work for both RBE2 and RBE3?
Yes, it should. Yes.
Okay, awesome.
All right. It should work for any rigid element. So that's both RB2s and RB3s. Okay, cool. Plane managers. So here's the dialog box. This is the dialog box that I'll be using to manage my planes, create new planes, show planes, copy, update titles, etc. So I'm going to go ahead and just create a new plane. I'm going to call this demo. And I'm going to locate this plane. I want to move this, my point 2 in the one direction, the Z, preview that. So I want to be right underneath my model here, this new plane. Okay, so now you can see my plane manager. There's a new plane that's there. Now I can, again, like I said, I can edit it, I can show it, I can update the title, etc. in this manager. So now this is saved to my model, right? So now for easy access, what I can do is to demonstrate it, I can go to Modify, Project. I want to project the node onto that plane that I just created using the plane manager. So I'm going to project this node right here. You can highlight it there, click OK. And I'm going to be projecting it onto a plane. And methods here. So this is where I was saying that there's a new option. If you look down here, there's a new saved option. So if I click that saved option, it opens it a similar dialog box that was for my plane manager, and you can see my demo plane right there. And click OK, accept that, and you can see how my node has now projected down onto that plane that I used or that I saved initially, and that can be accessed at any time. So again, it's just making processes of planes and vectors and processes in general for the analyst to make it easier for you, more streamlined, so you can finish your analysis quickly and take your products to market faster. All right. So nice and sweet demos for you all, just to see these updates. Again, reach out afterwards with any questions. Okay. Geometry manipulation. So this would happen during like pre-processing before you run your analysis. You want to toggle or play with the geometry to make it easier to mesh or model. So in this case, I won't be demoing this one, I'll just be explaining it. But in this case, you have a geometry here with a series of curves. These curves intersect at multiple points. And you as the analyst, you want to break this model down, or this part down, into a series of curves to make it easier for you to model. So now there's a new function, which is under Modify, Break, at all intersections. And as soon as you click that, the system is smart enough, the program is smart enough to know at what points these curves intersect, and it'll break them down into a series of curves that you can now model and mesh to your liking. With the function table editor, there's some updates to the GUI. With these editors, the function types, I mean, you can do time, temperature, stress, strain, frequency, dependent dynamics, thermal flow, and others. And with the table types, you can load set combinations, result set processing, thermal flow. And more on the GUI, there's a new GUI-based tool function in table editor, where it enables you to now copy and paste cell to cell. You can fill down, fill right. You can adjust highlighted cells with scale and factor, and ramp equation from data series. So again, FEMAP has improved for you as the analyst to perform your tasks faster. It's all about getting your analysis done quickly.
Hey, Edwin, one more question from Dan.
Yeah.
With the curve, when the curve split up, will the curve split option work if they're associated with surfaces and or solids?
with surfaces and or solids? Thanks for the question, Dan. I would have to further explore that. I know I've done it with just sketches like it is like this. I personally haven't explored it with surfaces or solids yet, but by all means, I'll get back to you as soon as possible with an answer to that. I can consult with some of the great CAE individuals at Saratech and Siemens. But yeah, as of right now, I can't give you an accurate answer. My assumption would be yes, it should work, because I think the system is smart enough to understand at what points it would intersect, and then it'll break it down for you. But I haven't personally done it, so.
Okay, perfect. Yeah, Dan, be sure to follow up with you on that. No problem.
Alrighty, some data mapping updates. Essentially, the data mapping, all that I'm going to be telling you here is that FEMAP 11.4, it's just the system was modified so it's faster to map data. It's about 1,000 times faster, and there's added data conversion methods, so you can do it from view or specified option like average, maximum, or minimum. And again, there's ongoing development on new source options, matching criteria plots, and contour plot options. Like I said, mapping times have decreased, my bad. So for example, a source model with like 1 million elements with nodal data distribution, in 11.3 will take around more than 5 hours, and now take 1 minute. It's just an update to the software itself, which makes it faster for you to map your data. All right, let's get into charting. There's a myriad or a number of improvements in the charting. I'll be showing two to three demos on the charting. So the first thing I'm going to show you is there's an updated GUI for the charting as well. So the charting data series dialog was redesigned to show only the most relevant information. I like to equate this to NX. I don't know how many of you have NX, but with NX, depending on which application you're using, the top pane or your options kind of change in accordance. So this it reduces clutter and options are easier to find. So with the data series, the data tab here, depending on the type that you select, the options will change. So I'll show that when I do the demo shortly. However, the style tab stays consistent. All right. So with charting, you have the ability to do real-time output processing. So processing is done on the fly by the charting pane, and manual processing is no longer required. You're able to do transform, nodal elemental data conversion, which is what I'll show you, and complex phase synchronization, which I will also be demoing for you. So let's delve into this. I'll be showing you the nodal elemental data conversion and the real-time output processing. All right, let's go to my model here. So we got this model. It's a plate. There's 2 through holes fixed here. There's a bearing load around this through hole over here. And let's show the results. So I've already ran an analysis. You can see all the information on the bottom left here. And the nodal contour that you're seeing right now is the plate top von Mises stress. Okay. Additionally, I have a group of my top nodes. So let's show that. And what I'm going to do is I'm going to be doing real-time or displaying the real-time output, nodal output, for these elemental stresses that you see here of these top nodes. Okay. So let's go over to the charting pane to show you how this is done. So you see, I already ran my analysis. You can see the results here, but I want to chart it dynamically. So I can simply go create a new data series. I'm going to do vector versus entity. Before I do this, actually, let me show you the GUI. So vector versus entity, you can see that I have, I can choose my x-axis, data source, output processing, right? I can also go to the vector versus set. You can see how it changes, right? So data source, they have different options for this. If you go to vector versus vector, different options. So again, this to reduce clutter, to streamline your process, so it makes it easier for you to know, or makes it easier for you to select the necessary options to perform your task. So let's go to vector versus entity. My x-axis values will be in position in the x position. My output set will be my curved hole, curved load, and I'll be doing my vector will be right here, which is the von Mises stress, which is 7033, is the ID. And my convert, I want to find the average von Mises nodal output per the top nodes. So that's the average output processing. I'm going to select my top nodes here, click OK. And there you have it. Simply Easily done, really quickly, simply, easily, quickly done. You can see my values. So this is average converted plate top on Mises versus the X direction. And it's a rectangular Cartesian coordinate system that I have. All right, cool. Let's head back here. Okay. Also, in addition to the dynamic charting, you're able to do simultaneous plotting of real and complex data. So you're able to show dual plots. This would be like for a to show a magnitude and phase data. So for like a frequency analysis, you can show both the magnitude and the phase data. And expansion is done automatically. There's no additional complex data series that needs to be specified. Also, the point right here in the bottom, there's a new chart data series type, and this is a complex expansion. So let's say you want to focus on a particular magnitude and see this magnitude in a certain range or a range of phase intervals that you define. So magnitude phase data is expanded at a user-defined interval. So let me go ahead and demo this for you as well, so you can see this firsthand. All right, so we have right here a plate element. There's a frequency displacement analysis run on this plate element, and it's fixed on the left end right here. So I'm gonna go, let me first show you the groups. So I have my output nodes. These are the nodes that, I don't know if you can really see it, oh, there you are. These are the nodes that I'm gonna be investigating in regards to the frequency analysis and plotting them. So let's go over to my charting pane. Do my drop down here. I'm gonna create a new data series. I'll be doing a vector verse set. I'm gonna be choosing an output set value. And my study is gonna be, like, as I said, frequency response to enforced displacement, which is this right here. My vector that I wanna look at is in the Z direction, T3 translation. And the nodes I wanna look at, select multiple, are my output nodes. Okay, awesome. Click OK. So you can see there's only one graph right now, and these are the outputs, the frequency nodal output for the 3 nodes that I defined, right? So in the Z direction. Okay, so you can see for node 22, 33, and 44, you can see that it's color coordinated. So now let's say I want to see it, the phase and the magnitude in separate plots. So this is where the new functionality comes in. So I can go over to my chart options and do chart options. And under the chart settings, in chart data, complex plot right here, this option right here, I can select top, do apply. And you can see right here, you have your phase diagram. So you can see the phase of these particular nodes and also the magnitude. So now you can see 2 separate plots, complex plots for your output. So let's go into looking at a particular magnitude at specified intervals. To do this, let's clear out our charting pane and create a new chart. So we can go over to create data series. And there's a new option here, as I stated before, which is the expand complex. So we have our complex model, and now we want to look at a particular magnitude of that. So I'm going to be going to my output set. I want to not look at it in a time response, but I'm going to look at a frequency. So it can be any, let's just do case 28, frequency 54. I want to look at it in the Z direction again, the T3 translation. My location, I want to look at this middle node right there. And my user-defined increment. So what phase angle increments will be looking at this magnitude. And I want to make this 10. And there you have it. So now you're looking at one magnitude nodal output per your frequency analysis for that one selected node. Kind of complex, but so when looking at this, so it says right here, it's case 28, frequency 54, and it's your T3 translation versus phase. So magnitude versus phase. Now I want to look at the max and min. You can go ahead to chart options, go to labels and markers, display labels, show max and min, apply, and there you have it. It tells you your max and min, magnitude, and phase values. Cool. That's actually the last demo, but I have more to present to kind of explain to you what the modifications have been made to 11.4. Nastran solver support. There's a few Nastran enhancements. This includes the parameter post -2, so this reads nodal output in the basic coordinate system. In addition, there's a strain curvature output support. Performance enhancements for reading large Nastran input files with many DMIG entries. You can read, keep, and cycle CLAS1 entries in lieu of auto-converting to CLAS2 entries, and the ZTOL entry support for Nastran radiation analysis. And lastly, this is with the API only, so this is with the FEMAP API, is the FE solid extract center lines. So you can pass in more than one solid for this particular function within the API. And in this example, it's just one single solid that's being passed through, which is this solid. You'll see in the next slide that it finds the center lines for you, and in addition, it defines the holes or the curves here. So it extracts center lines and arcs. It assigns properties and materials. So you have the ability to do this using this new method within FEMAP API. For solid tubes, FEMAP's circular bar property is created, and then conversely for hollow tubes, a circular tube is created. It's all within a single call to command. Properties are reused if they match. And for non-circular cross sections, lines, arcs are created on neutral axes of section. A property is assigned to each curve. There's no attempt to consolidate each curve or assign a new property. So it's all done at once within the API program as soon as you hit run. I think this is the last slide. But with the solid center line finder, you can do this for 69 solids, or you can do it for one solid. So it doesn't matter. The system is smart enough to know where these tubes are, and it'll find the center lines and the arcs for you. Again, this is within the FEMAP API. It's a function within it. And on that note, I think I'll be passing it back to Andrea to conclude this presentation.
Great job. Thank you, Edwin, and thank you guys for participating. We had some really great questions today. And as you go through your day, if you have any other questions about any of the updates or want to see anything up close and personal, just let us know, and we'll make sure that Edwin follows up with you. So if let's see. Oh, okay. Our next CES session is going to be on Thursday, August 17th on SimCenter 3D value-based licensing with Dan Rubio. Next slide. All right. And of course, we have the wrong title on the last slide. Please excuse that. But a lot of you already know this, but just in case you don't already know, we do offer hands-on training classes for software users of all levels, from beginner to expert. And we also offer lots and lots of services. Our services department is really swinging these days. So if there's any kind of services that you are interested in, please let us know. And then also we have some great additive manufacturing options as well.
I can attest to that. If I can jump in, the services group, I mean, me as a new engineer with Saratech, we're always excited to get these new projects. So whenever a new project is presented to us, we're always really attentive and always excited to speak to our clients to see what these projects are and how we can contribute to your company's needs and projects. So sorry for interrupting.
It's very exciting. Okay, awesome. Thank you all again for attending. If you could just stick around for about 30 seconds after the webcast closes, it would be so awesome to get your feedback. Let us know how we did today, what we can do to improve in the future. Like I said, we do a few of these every month, and we really appreciate your feedback. It gives us a lot more experience and just helps us to improve every single time. We will be posting this to YouTube today. Make sure that you subscribe to our YouTube channel so that you can see all of the new webinars and trainings and all kinds of great tips and tricks that we post on there all the time. And of course, follow us on our other channels. So with that, we hope to see you again in just a couple of weeks for the SimCenter CAE webinar. And thank you again for joining us. Have a wonderful day.